Today, my name is Carlo L. Padilla, and I'm going to be discussing the first part of our thesis, which is entitled Design and Development of an IoT-based three-phase pump motor monitoring system. So the other proponents are Lipat Nel Mikael I and Alagar Jan S. So to start, I'm going to be first discussing the summary of process and the problems on why we came up with this prototype. So first is the summary of the process. So we have three major processes. As we can see, we have the data acquisition and the transmission. The last part is the uploading into the cloud. So why do we need, or why we came up with this idea? First, the problem is in water district, they have a lot of pump motors, and those pump motors are checked manually. So they have to go there and kailangan nilang puntahan yon, and na-check lang yung mga motor for their efficiency quarterly. So hindi nila masyadong na-monitor, hindi nila masyadong na ano. That's why nagkakaroon ng mga maraming problema sa mga motor. So the main problem here is the lack of monitoring. So through this, ma-solve namin yung problem. And first part is the data acquisition, in which we'll measure the given parameters of the motor, the value of the current, the voltage, the power, whether it is efficient or not, the power factor, and then after we measure the given parameters, we will send it to our base station. So through LoRa, our transmission device, we will send it to our base station, and then as we can see in our base station, there is a Raspberry Pi, and this Raspberry Pi will upload it to the cloud or to the internet or to the web or to the website. So we can view it through our website. Just click and we can see the values of the motor in real time, and we can also check the data. For example, for the given day, we can go back for the maintenance purposes. So that's it. The next part is the objectives. So as you can see, we have an old and new objectives here. So since we cannot deploy our prototype due to the pandemic, we have to make a simulation. So the first objective is to design the three-phase motor monitoring system considering the following. The first is design analysis and computation. Next one is the materials and components, circuit diagram, programming of codes, and the web design. So compared to all the objectives, these design standards became number 2, or it's just the same to develop and construct the monitoring system using design considerations or standards. So that's why we remove it, and the design computation became design analysis and computation. So we add analysis up there. So next one is materials components, it's just the same, also with the circuit diagram. So with the web design and cloud database, we make it web design and programming of codes. So for the web design, we think that it is included in the cloud database is included in the web design, so we make it just a web design. So the next one is to perform a sequence of tests, specifically the following. The first one is the functionality test. Second is the latency test, current and voltage measurement accuracy test, and the last part is the simulation. So as we can see, we have other tests here that we cannot make because we cannot deploy our prototype, just like this user acceptance test. So we cannot interview or we cannot make interaction with other people, those in water district. So we cannot already make it. So other tests will became simulation part. So that's all for the objectives. Our prototype will be able to monitor the following parameters. The first one is the voltage in unit of volts, the current in unit in amperes, the power factor, the temperature in degrees Celsius, the power in kilowatt, and also the efficiency. So this prototype will not only measure those current, and it will also send alerts whenever the following are detected. So the first one is overheating. Next one is the low efficiency. And the last one is the single phasing, which is the most important part of our system. So in single phasing, at normal operating conditions, we have phase A, phase B, phase C. We have 100% full load current. So we have an approximately equal current for it to be in phase. So when single phasing occurs, phase A goes down and magsasubstitute yung phase B and phase C for the loss na nawala phase A. So yung motor, magko-continue pa rin siya mag-function without knowing na may problema. So with this, with our prototype, we can determine whether there is something wrong to the motor or whether it is single facing or not, because single facing affects greatly the performance of the motor. So what are the components, or what are the components that we use in our prototype? So the first one is the PZEM 0040 TTL Modbus power meter with clamp meters. So these clamp meters is connected to the three-phase or to the three-wire of the motor, whether it is located under the panel board. So this TTL power Modbus is a simplified measurement tool to measure current and also the power, also the efficiency and the power factor. So the next one is the Arduino Mega 2560. So we use this Arduino Mega 2560 since it has a lot of inputs. So next one is LoRa NRF 9596. So it's our transmission device. It is a low power and comes with great range and but low bandwidth. So but with this we can use two frequencies, and 915 and 868, which later will be discussed. So the next one is the 5 volts 10 amperes regulated switching power supply. So we use this because our Arduino and LoRa will gonna be needing little currents, approximately from 1 to 2 amperes. So from 220 volts, we're gonna be stepped down in to 5 volts for the purpose of Arduino and the LoRa. So Raspberry Pi, we use this Raspberry Pi for our base station, and it will be the one who will send it to the cloud. So for the software part, we're going to be using Node-RED and Grafana. So to detect or to measure temperature, we're going to be using temperature sensor. And to protect our prototype, we used weatherproof panel box since our prototype is supposed to be installed outdoors. So for the bill of materials, for the quantity of one Arduino, that costs 700, 2 pieces of LoRa, which costs 2,000, 1 piece switching power supply for 1,500, and 3 pieces for power meter that will cost 1,800, and 1 piece temperature sensor costs 100 pesos, and 1 piece also Raspberry Pi for 3,000, and also 1 piece weatherproof panel box for 2,000. So we spend, for 1 unit, we spend 11,100, and for 2 units, we spend 22,200. This is the construction process. So we have 3 major processes in the construction. So the first one is the initial testing, next one is the construction, and the last one is the testing and simulation. So under initial testing, we have functionality tests for Arduino, LoRa, power meter, Raspberry Pi, and temperature sensor. So to determine whether it's functioning or not, since most of our components are bought online, so we have to whether know it is functioning or not. So for Arduino Mega, we made a test, which is the functionality test, and the remarks is functioning. So for the LoRa, we made a functionality test also, but we made another test for it, which I will be later discussing on. And because LoRa has a lot of considerations for it to function better. So for the power meter, we test whether it's accurate or not, and also the functionality test, and with this we can say that it's functioning. Raspberry Pi functionality test also, the remarks is functioning. Temperature sensor functionality test and functioning. So the importance of this functionality test, for example, the first time we bought Arduino Mega and we test whether it's functioning or not, we realized that it has a problem, so we change it immediately. So this shows how important this functionality test is. So for the LoRa, we made a lot of tests for the LoRa to know whether when or how will it function better. So we can see here RSSI values. So these RSSI values will tell us whether the transmission is better. So the closer it is to 0, the better the transmission. So the LoRa can function without antenna and will also function with antenna, of course. So we test it whether it is good to use antenna or not. So LoRa without antenna will give us negative 102, and with antenna will give us negative 69. This comes with same distance, and so for this we conclude that LoRa with antenna will function better. So the next one is the LoRa with Arduino as its power supply, and LoRa with its own power supply. As I said earlier, LoRa is a low power device, so it can be only powered by Arduino when it is connected to it. So you can see also the RSSI values. You can see that it is negative 105 when it is connected to Arduino, and when it has its own power supply, it is negative 54. So we can see the difference, and we can conclude that LoRa with its own power supply will function better when it is not connected to Arduino. So next one is LoRa 868 frequency and LoRa with 915 MHz frequency. As I said earlier, it can be set with two frequencies. When we bought it, we can use it with 868 or 915. So we test it with the same distance again. We can see that RSSI values is negative 45 for 868 frequency and negative 65 for 915 frequency. So in this, we conclude that LoRa with 868 MHz frequency will function better, so we use the LoRa 868 MHz frequency. So next one is the LoRa response times test. So it will tell us whether it can show or can measure data real time or can send data real time. So first trial, you can see the time on the time elapsed is 0.05 seconds. Next one is 0.02 seconds for the second trial. Next one is 0.011, 0.018, 0.016. So based through this data, we can say that we can use our prototype in real-time monitoring. The next test is the measurement accuracy test. So it is a test to determine whether our power meters are measuring accurately. So we compared it to the readings of multimeter with known accuracy, and these are the readings of the multimeter, and these are the readings of our power meter. So we compute it to determine its percentage error, and as you can see, the values 0.07, 0.01, those are a little amount or small amount values, and with that values we can say that our power meters is accurate. So next one is the stress test using dummy load. So makikita po natin, gumamit po kami ng saksakan and tatlong saksakan to represent our three phase. And ito po namin connect yung aming mga power meters sa mga single wire. And then tinest namin kung gagana siya, kung withstand niya yung stress, since yung aming prototype ay gagamitin for 24 hours or more, or tuloy-tuloy, or kailangan nating malaman kung gagana siya for a long time. So after the test, we conclude that it will function and can be used for monitoring purposes. So next one is the construction. So we just assemble, and you can see we connect where it should be, and we use rubber here for the insulation, and we just assemble it, and that's it. Our prototype is done, and the next video will show the simulation since our prototype cannot be deployed. That's all. Thank you.